Hey y'all, I'm Marcella Windmuller-Campione, and thanks for being here with me today as we take a tour of a forest that looks a little different. For those of you that know me, also want to share, I get to call myself an associate professor. So I look forward to hopefully being in person next year to celebrate many things, but that being one of them. So today we're going to be talking about floodplain forests along the upper Mississippi River, and we're going to be doing this within an urban environment. So this is the first affiliate of the Adaptive Silviculture for Climate Change project that's in an urban environment. So before we go to the site, I want to acknowledge the lands of the University of Minnesota, as well as the lands that are the lands of Crosby Farm, and want to take a minute to acknowledge the historic, current, and future stewards of the land. And also want to acknowledge that this is a huge collaborative group and project and experiment that relies on so many individuals and so many people coming together and working on this project and working through the logistics. So one of the pieces that precedent this project is Minnesota's climate is changing. So we're seeing changes in temperature. We're also expected to see changes in precipitation. And in Minnesota, we're seeing that increase, especially in this kind of southern extent of seeing a lot more precipitation as seeing a lot more precipitation over the last 100+ years. And that precipitation is not just the amount, but also these huge historic mega rainfall events. And within 2000 to 2014, 5 mega rainfall events, including, and it's not on this graph, including a huge rainfall event during 2018, I believe, or it was 2019, it might have been both years. And then now a very historic drought. So we're seeing big shifts in precipitation. And so that brings us to one of the locations, the location that we're going to be at today, and that's Crosby Farms Regional Park. And this is the largest natural park in the St. Paul system of parks. And to give you an idea of where we are, so the Mississippi River is here. We will be looking at sites over here, and we'll be going out in the field too in different videos. But we are in an urban area. We are very close to McDonald's, very close to a candy store. We are within an urban space, and one that is, there's houses and apartment buildings, and the cities, both the Twin Cities, Minneapolis and St. Paul are not far away. I mean, we are in an urban environment. And that environment is seeing a lot of change. And these floodplain forests of Crosby Farms were dominated by ash, a lot of green ash, and emerald ash borer has already been through here and created this this scene was, this picture was obviously taken after the growing season and right around that October period, but it very much fits kind of this spooky scene, dead trees, vines, and just a huge amount of dead. And so just to kind of refresh, emerald ash borer, 95% of the trees at Crosby Farm in the area we were working with were ash, and almost all of them were killed by EAB. And also new regeneration isn't happening naturally. And so ash is widespread, and there's a lot of fear in terms of like the impact that EIB will have on northern forests, especially black ash. And those of you that were on the tour a few years ago when the convention was in Madison, we saw some of those forests, the black ash forest, and we talked about that impact. But where a lot of the current distribution of EAB is in the Minneapolis and St. Paul metropolitan area and along floodplains. And so floodplains are super dynamic systems. And this is a picture, and you might be saying, oh, I see regeneration. I see tons. And you're right. This was after a flooding event. And there was a carpet of silver maple seedlings, just a carpet of silver maple seedlings. However, there's also a lot of other species, some native, some invasive, that also do really well upon the floodplain. So this is the control plot, and we'll go into that I went into that a few days ago, and it looks a little different, but this is a control plot from the summer. And what you're seeing is probably garlic mustard and the start of a lot of nettle, and not a lot of regeneration. And we did look for it. And I say I was out there for about 4 to 6 hours, but my graduate students and undergraduate field tech, thank you so much, Austa and Nick, did look for it. And so we were looking for that regeneration, especially since you might notice there's fencing. So we fenced to see, like, is regeneration happening if we fence? And we didn't see any yet. And so one of the most common questions from managers is what should I plant? Regeneration isn't happening. I have overstory mortality. And how do I maintain a forest system? And so that's where this broader network of the Adaptive Silviculture for Climate Change Network really comes into place, and thinking about these questions. And I know many of you are familiar with this network, are part of this network. And so it's just amazing to see the extent and the range of how many sites there are. And so pre-pandemic, we were able to do an in-person workshop and work through these aspects related to resistance, resilience, and transition in an urban environment. So this is going to look a little different than some other forests that have a lot more space. And you'll see that it looks a little different. It looks a little different given our setting. And so we still maintain the same setting with resistance, resilience, and transition. And I touch on this in the video, but our resistance treatment really focuses on planting and regeneration, planting of species from Crosby Farm and kind of this floodplain forest in this Minnesota area. Our resilience, we extend that out to floodplain forest of kind of this broader upper Mississippi River basin. So that can include Iowa, that can include Wisconsin. And I should also mention, so our resistance are zone 4, our resilience is zone 5, and our transition is where we extend to the northern extent of the southern bottomland forest. So bringing those species in, and those are all from zone 6. And so with this experiment, we're really focused on the planting aspect of silviculture and that artificial regeneration. And so we collected pre-treatment data on the sites, and you can see the nettle that's there. And given this is an urban environment, and this is an urban environment that has hundreds of thousands of visitors every year. So a hugely utilized space. We utilize the already formed gaps that EAB created. And this was for a few reasons. So those gaps were there, and so that was good. There's also that public perception of removing trees. And so we utilize the gaps as a way to say, to work with public perception and work within that. And then there's also just the cost. I mean, this all had to be paid for. So none of the harvesting was profitable. So this all had to be paid for through grants, through cost shares, through so many aspects to do the harvesting. And so here's kind of the locations of the gap. So, and this is the trail system, and the trail system you'll see when we head out to the site. But there's this wonderful trail system. So these plots are adjacent to the trail, are visible from the trail. And that was a conscious choice to allow this experiment to be part of the park and to be part of that. So there's been also a huge amount of work working on signage and information and sharing what we're doing. And every time I'm out there, every time someone is out there with this project, there's always at least one or two people that are so interested in what we're doing. So I've gotten to say silviculture more times to people that look at me and explain what it is, and it's just awesome. So there's so much interest in what we're doing and why we're doing it, especially when we frame it as we're replanting trees and regenerating the forest. And so these are our units. These are plots. So we have 24 1/10 acre plots. And so there's 6 replicates per treatment plus the controls. And so these gaps were cleared through multiple different crews, multiple different organizations, one to allow for the site to be set up, allow for our planting, and allow for safety. And so with our species selection, this was a big part of the conversation and thinking through what that is. So our resistance, maintaining relatively unchanged conditions over time. So we have our silver maple, American elm, and that's the disease-resistant variety, cottonwood, hackberry, and river birch. And these are all from zone 4, like I previously mentioned. We have resilience, allowing for some of that change. And so we see a broader species mix with silver maple, American elm, cottonwood, black willow, river birch, bur oak, American sycamore, swamp white oak. And these are nurseries from plant hardiness zone 5. And then you'll see silver maple is also from zone 4. And then transition, that's where we moved really far south. And so we're in zone 6, and we've got silver maple, red maple, American sycamore, river birch, sweet gum, southern pin oak, honey locust, yellow poplar, or tulip tree. And these are all from hardiness zone 6, plus silver maple from zone 4. So one of the pieces in these floodplain ecosystems is they're so dynamic. And we did our best to really try to find locations that were as similar as possible. And even though we're within a relatively small space, we're at varying distances from the Mississippi River. You also saw another body of water. So there's huge potential for those dynamics to influence this. So we did try to block, we did try to take into account of that. But we also wanted to have silver maple as kind of a constant across all of our plots, just to be able to see and compare, are we seeing maybe what we're seeing based on the plot location? Are we seeing this based on the treatment? And just be able to also add another level to tease out some of what we might be seeing. And so we set up for planting 1,200 seedlings, and these 1,200 seedlings were all individually marked. They were all mapped. So this is still within that research study, research design. And we did it with volunteers, and we planted during a pandemic. And so these were volunteers. So one of the big partners is Mississippi Park Connection, and they are just amazing individuals, amazing organization. But this was my first time working through something like this, and I was super skeptical, but it went really, really well and really, really smoothly. And there was a lot of logistics that went into ensuring that this could work. So you'll notice multiple flags. So volunteers would grab a flag and then grab an associate tree that matched the flag, and then put the tree in the ground as well as the flag. And so you're also maybe seeing some big trees that were going in the ground. So we planted large bare root stock. Our goal was greater than 6 feet in height. And one of the pieces was really thinking about those flood dynamics of small trees can get flooded out. And so getting trees in the ground that are tall so we can keep them above water. Our trees are planted at roughly 10 by 10 spacing, and every location was marked and every tree was marked. And so it worked. And so the planting went, and we saw growth, and we saw the trees leaf out. And so from that, we built on getting continuous temperature measurements. So we have measurements of temperature in all of the 24 plots, including the controls. We have weekly phenology measurements that started this year. So 2021 from spring, and we're just finishing up those. And we have our second year of growth and condition. So we, at the start, we measured initial diameter and height, as well as quality. Throughout that first growing season, we had multiple checks on the kind of quality or health. And then we finished out with an end of season growing measurement. We started season 2 with another check-in because there was some dynamics in the floodplain that can allow trees to become zombies. So they can be recorded as dead 1 year and then resprout. So that's we saw that happen with some of our cottonwoods. So some of the cottonwoods were noted as dead at the end of growing season 1, and then were live the start of growing season 2. So we really wanted to try to capture that potential dynamics that is a little different than other systems. So that way we knew who was alive at the start of the spring. And then also we're just finishing up end of growing season measurements here as we speak. And so preliminary results from our first growing season, we had a lot of trees that lived. Almost 87% of the trees lived, which is just amazing. All of these trees were planted by volunteers. And we saw really high survival, both in terms of numbers of individuals and number of trees in both the resistance and the resilience. So these are trees that are generally from the floodplains and from the region. We had higher mortality in the transition treatments, and red maple, river birch, and tulip poplar had some of the highest mortality, but other trees like sycamore and southern pin oak had great survival. And with that kind of red maple, river birch, and tulip poplar, a lot of those trees, we saw no sign of them switching from dormant to having any sign of life. So our hypothesis is that we either got bad stock, or because it was a pandemic and these trees were traveling from Tennessee or Missouri during a pandemic, we just might have had some really bad conditions in terms of that transport. So it was likely that these trees never were alive, and we never planted live trees. So, which is a bummer, but it's also really, I guess, it's one piece of the puzzle of like transporting these species. It takes time and it takes a lot of logistics. And so in terms of thinking about those condition classes and thinking about health, we saw very little change in the transition treatment. So those trees that were alive in 2020 and looked pretty good were generally looking pretty good. So 2 was our highest one of like looking great, looking healthy. 1 was like there was something going on, and 0 was dead. But we saw a little more of that transition, or a little more of a potential decrease in our resistance and resilience. But these are super, super preliminary results. And so let's head out to the site. So I'm going to switch over to the video that was taken just recently. I want to thank a graduate student, Ella Gray. She's a PhD candidate working with myself and Dr. Matt Russell. She graciously filmed me. So we're going to head out to the site.
Hey y'all, we're out at the field site. So thanks for bearing with me as we transition from PowerPoint to iPhone video. So welcome to Crosby Farm. So I just had the opportunity for a lovely 15-minute walk along a nice paved road, which I know for some of you going into other field sites that we're seeing today is a lot different. So welcome to Crosby Farm, and welcome to the first urban adaptive installation of the Adaptive Silviculture for Climate Change project and network. So as you can see in this broader background, we are in the floodplain forest of the upper Mississippi River. So we see cottonwood, we see dead and dying green ash, we see box elder, and just a whole host of other species. And like I mentioned in the PowerPoint and in the setup, regeneration isn't happening. If we were here in the summer, you would see waist to shoulder high nettle. And we looked for regeneration this summer under that nettle. And by I was out here for about 6 hours. A graduate student, Elsa, and a field tech, Nick, were out here for multiple days looking at that before we did any kind of treatment to see if we were getting natural regeneration. So we have that data, but and what we found was regeneration is not happening. So now we're not seeing regeneration, we're losing the overstory canopy, and now tackling that question of, if we don't have regeneration happening naturally, what can we plant and what does that look like in terms of climate adaptation? So first plot we're going to go into is the transition plot. So bear with us as we move in there, and we'll see you in a second. The transition plot. So like I mentioned in the PowerPoint, these are 1/10 acre plots. They are surrounded by 8-foot deer fences that are all staked into place. So these are all protected seedlings, 1/10 acre plot, and this plot size is replicated 24 times. So a pretty big plot when we think about this being an urban area. And I also want to show what you're seeing behind me are trees in their second growing season, just finishing up their second growing season. So these are some of our bigger trees. And with the transition, these are our species that we're planting from kind of that northern extent of the southern portion of floodplain forest, so that Missouri, Tennessee area. So we have sycamores in here, which are just really doing extremely well. The transition plots, if you remember, also had our highest mortality. So a lot of the mortality happened in the transition plots, and many of those tree species we think were never actually alive when we planted them. So the combination of traveling on multiple different means from Missouri and Tennessee during 2019 with COVID just did not result in great survival, or we might have not just had bad stock. So the species that did have really good survival was sycamore. You also are seeing silver maple. So silver maple here is both zone 4 to kind of be able to compare across the different treatments. And we also have zone 6 silver maple. So all these species are labeled. You maybe are also seeing our monitoring for temperature. And I want to take us over to a few other species. So I mentioned we were trying to get really large stocks. So the idea with the stock size being that if we had a flood, those trees would be over and not be flooded out. A species that we weren't able to get that higher stock size, but we still wanted to include was pecan. So this might look a little more familiar with from other plantings in other situations within forestry. So I believe this was our smallest stock at 2 feet, and our largest stock with the sycamore and silver maple was about 6 to 7 feet. I want to highlight one more tree in here, which is tulip poplar. So this tree did not have great survival, but when it did survive, it's looking really good. So all the trees are permanently, are marked with nail polish for us to be able to measure diameter, DBH, as well as basal diameter. And we are currently doing those end of growing season measurements right now. And those measurements are being conducted by undergraduate students in different classes. They're being conducted by volunteers, as well as being conducted by individuals within my lab and within the broader civil lab. So there generally is someone there that is associated with this project to kind of oversee, but the measurements are part of the learning experience as well. The resilience treatment. And as you're kind of seeing in the background, there's a whole lot more trees that are alive, and a whole lot more trees that are above my head and getting into that 10, 11, 12, 13, 14. I think our tallest tree at the beginning of the season was 17 feet. So they're getting tall. And so our resilience treatment is slightly south of us. So these are zone 5 trees, and they are trees within the broader floodplain forest of the upper Mississippi River. So that includes Minnesota, that includes Wisconsin, that includes Iowa. So this broader region that may or may not be at Crosby Farm, but is part of the broader upper Mississippi floodplain forest type. So we have swamp white oak, and these actually had to get staked because they were growing too quickly and growing too tall. So this is an example of one that's a little shorter, but in some of the other plots, they were falling over. So we staked all the swamp white oak across all the treatments. Again, we have silver maple, so silver maple from zone 4, as well as silver maple from zone 5. We have river birch, and river birch is already starting to get that charismatic bark that we're seeing, and that charismatic sloughing that's happening, as well as cottonwood. And cottonwood's been a really interesting tree to work with. So within the floodplain forest, sometimes we have zombie trees. And so cottonwood is one of those species that after the first season, we thought they did not have visible signs of life. So they were marked as dead, but many of them resprouted. And so now we're looking at trees that have grown exceptionally well, even during this drought year. So we're seeing some of these trees that were always alive, but also some of these trees that may have been recorded dead, but then have resprouted and done really well. So we have cottonwood, and then also in the back, we have willow, as well as disease-resistant elm. So a whole host of species here, and really in general, low mortality in both the resilience treatment and the resistance treatment. So we're going to head over to the resistance treatment next, and also show you one of the untreated controls and unplanted controls. Awesome, thanks. Treatment, and also getting a little bit of our fall colors. So our resistance treatment are trees that are local, so zone 4, and they are also trees that are within Crosby Farm or really pretty close proximity to Crosby Farm. So these are all zone 4 trees, and the resistance treatment had really, really high survival. Both resistance and resilience had generally over 90% survival across all the species. So most of our mortality occurred in the resilience treatment, or in the transition treatments. And so we have our silver maple, again, as well as a huge swamp white oak that maybe is a better example of why it needed to be staked. Some river birch, as well as a few other species, including elm, Dutch elm resistant elm, as well as cottonwood. And so as this project continues into the future, there's going to be a lot of really, really interesting questions related not only to how these species grow, which is pretty much understudied in these floodplain forest systems, but also thinking about how these communities work together, or what that relationship is. So there's a lot of interest not only thinking about how the tree species interact with each other within the different treatments, but also how these different tree species interact with wildlife species, as well as insects and other aspects. So there's a lot of interest thinking about these pieces together. One piece that I forgot to mention is with these cottonwood, especially the large ones, those are great nesting habitats for bald eagle. So there's a lot of want to have big, large canopy trees to provide nesting habitats for eagles, but also the whole host of other bird species that either call the upper Mississippi home or migrate through the upper Mississippi flyway as they make their way both north and south, depending on the migration season. So with that, we're done in the resistance plot, and finishing up the tour, we are in a control plot. So as you can see, nothing is planted, and thankfully we're at the end of the growing season. So it's comfortable to be in here. So like I mentioned, during the spring, during the summer, this is a plot full of garlic mustard, full of nettle, and not full of tree seedlings either. So our first year, we did mow every single plot and did treat every single plot through weeding treatments. This year, we chose not to do that within the control plots. You can also see the surrounding area of like what we were able to remove in general was the ash within the plots. So this was not a commercial harvest. This was a harvest that required a lot of input in terms of both money and resources to be able to get these trees removed and removed safely. But we were not able, for a number of reasons, to remove the surrounding areas from the dead or dying ash. So behind me, you can see a great example of a tree that has fallen due to wind, due to a lot of other things. And may hopefully get taken care of this winter. But that's also something that we are continually working with, both with crews within my lab, but more importantly, the volunteers that work with Mississippi Park Connections are out here weekly checking on the plots to make sure the fencing stays up and the tree hasn't caused it to come down. And that weekly monitoring happens throughout the year. So including the winter, folks are out here checking and just checking to make sure fencing is staying up and these trees are being protected from deer and herbivory. So this is our control, and this is an area that we're really interested to see what happens when we do have this area protected from deer herbivory. Will we see natural regeneration, and will that regeneration potentially be when we have a larger flood event and a shift in the substrate here? So lots more to hopefully come in this plot with future dynamics, but right now, not much regeneration happening.
So that's it, folks. Thanks for watching, and I welcome questions.